Systems of loop equations 1. Determine the current through each underlined resistor. So the current that we want to know is going to be the one going through that resistor. We're going to have to set up a series of equations here, a couple of equations, and we're going to solve those, and hopefully we'll figure out that the answer is 0.25 amps. Let's try it. What we do here is we assume that there are some currents flowing through here. Now, we don't necessarily know which way the currents are flowing, but I'm just going to say this battery, directed as it is, I'm going to guess that there's a current going that way. And over here, because this battery is oriented as it is, I'm going to assume that there's a current that is oriented that way, which means through this 4 ohm resistor, we would have a current. We could call it I3, but that would introduce a third variable. So instead, by Kirchhoff's junction rule, I1 and I2 are both flowing into there. So let's call it I1 plus I2 going that way. And then you can see what happens down here by Kirchhoff's junction rule. I1 plus I2 flow in. I1 goes this way. I2 goes that way. So everything's consistent. All right, so that's the first thing. You identify your unknown currents. Now what we need to do is we need to write 2 loop equations because we have 2 unknowns. It doesn't matter really where we start or which way we go, but I'm going to start on the left loop here. That is, we're just going to go around the left side, and I'm going to start and end at the dot that I put in there, and I'm going to go counterclockwise. I like to go in the direction that my assumed currents are going because then it's always minus IR, but it doesn't matter. All right, so let's do that. The first thing we run into is the 3-volt battery, so that's going to be 3. Then the next thing we run into is going to be this 2 ohm resistor, so we're going to go 2 times I1, and that's negative because we're going around the loop in the same direction that our assumed current is going. But before I do that, look what has to happen here. We're going to end up back at the dot, which means this I1, it's going to combine with I2 coming through the middle part of the circuit here, but then it's going to be I1 by itself again. So in other words, I've got 2I1 up here, and then I got another 2I1 down here. So I'm going to save myself a little time by saying minus 4I1. That's the top resistor here and this bottom resistor. Now, we have to go through the rest of the middle part of the circuit as well, right? So we've got 3 volts that we go up, then we're going minus 2I1, and then we know we're going to go another minus 2I1 down here. But in the middle, we've got to go minus 4I1 plus I2, and then we're going through this battery opposite the way it's pointed, so we have to go minus 6, and that equals 0. Now, if we simplify that, what does that leave us with? The 3 and the negative 6 give us negative 3 volts, and then what do we end up with? A total of negative 8 I1 and negative 4 I2, and that's going to equal 0. All right, so that's one loop equation. Now we have to write a second loop equation, and I'm going to go around the right loop this time, and I'm going to start at a star. I'm going to put a little star right there, and I'm going to go counterclockwise. Did I say counterclockwise for the left one? I meant clockwise. Oh well. All right, so here we go. Start at the star. The first thing we run into is the 6-volt battery, so I'm going to write 6 there. And then we're going to end up with minus 2I2, but as before, watch what happens. This I2 goes right here, and we're only going around the right loop, so we're going to end up going through here and doing some things, but then we have just I2 again, and we're running through another 2 ohm resistor. So as before, I'm going to just add those up all in one step to save myself a little bit of space here on the paper. That 2I2 and that 2I2 give me a total of 4I2, and it's minus because we are going through those resistors in the same direction that our assumed current is going. All right, and then when we get to this middle portion, we have to say minus 4 times the quantity I1 plus I2. And once again, now we're going through this battery in the direction opposite that it's pointed. So we have to say minus 6. All right, so what does that give us? Well, this 6 and that 6 cancel each other. And if we put the I1 first, that leaves us with negative 4 I1 minus 8 I2 equals 0. Now we're going to use a calculator to solve this system of equations. And as we said in the last video, the way you proceed is you take these equations and you put the constants on the right side, and then you put all the variables on the left. So I'm going to put this constant on the right side where it becomes positive. I'm going to have negative 8I1, negative 4I2, and then a positive 3. That's this first equation right there. Then this next one, there's just a 0 for that. And this is negative 4 and negative 8, but can't I multiply the whole thing by negative 1, and that'll make these positive? That's going to make it a little bit easier. So there's my matrix that I need to type in. All right, here we go. Let's pull this up. Turn the calculator on. Let's go to second matrix. We're going to go to edit, hit enter. This is a 2x3 matrix, so we're all good there. And now we're going to put these numbers in. We're going to read them just like a book. Negative 8, enter. Negative 4, enter. 3, enter. 4, enter. 8, enter. 0, enter. There you go. Let's quit. Let's go back into matrix. Now we're going to do math on this. We toggle down to, I believe it's number 9. Nope, it isn't. There it is. It's letter B. RREF. That's what you want. Now you need to tell it what matrix to use in there. So we're now going to go enter, and we're going to go second matrix, and it says, hey, do you want me to put matrix A in there? And we hit enter, which means you betcha. And then we hit enter, say solve it. Now what does that tell us? We got I1 is negative half of an amp, and I2 is a quarter of an amp. So let me write those in there. I1 came out to be negative 1/2 of an amp, and I2 came out to be positive a quarter of an amp, which means what? Well, it means that I chose the wrong direction for I1. I assumed that it went this way, as you can see at the top of the screen here, and in reality, it goes the other way. No big deal. Okay, who cares? I happen to guess correctly on I2 because you can see I2 is a positive number. As long as you are consistent, you're going to get the right answer. Now, the original question was, what's the current through this 4 ohm resistor? And we said it's going to be I1 plus I2 in this downward pointing direction. I1 plus I2 would give us negative 0.25 in the downward direction. And look at that. Doesn't that mean that we get 0.25 amps in the upward direction?